Hello everyone, welcome to this new video in which we're going to solve the Vuln Recruitment Medium Challenge. If you don't know what this is, then check out my first video about this website, ctfchallenge.com. There are many web security challenges that teach you how to approach a target, which can be very useful in bug bounty hunting. We covered subdomain enumeration, content discovery, open redirect server-side, brute force hashes based on how they were generated, did some open source intelligence to bypass the security question. We did a lot of things here. We leveraged the SSRF to gain access to the admin subdomain. So let's get started. Alright, let's click on the challenge and hit begin challenge. First of all, let me update my Chrome browser. It's always a good idea to have a newest version of your web browser, otherwise you're open to exploits around the world. Alright, let's continue. We have staff members, which lists the employees of this company. If we go back to the list of challenges we have here, this recruitment company has a serious security problem, but you'll have to dig into its past staff members to work out how to get in. Seems that we need to do some open source intelligence on those members, but before that let me just use burp to record the requests and see if there is something that we miss. I'm going to just revisit those members and click on each one of them. You can see that we can control the ID here. Oh, so staff member no longer works for Vuln Recruitment. 5 staff member ID is invalid. So it seems that we have 3 employees with one with ID 3 who no longer works for Vuln Recruitment. Let's actually go to burp and see what are the requests that we generated. So this was the home page. I don't see anything suspicious here. By the way, if you hear a background noise, that's our neighbors who are partying, so apologies for that. Okay, so we have the style.css, which returns apparently a 404 not found. Great, so we don't have any CSS. When we go to staff, we are presented with the HTML page pointing to each employee member with their image. It seems that it's fetching that based on their IDs, as you can see here. Okay, so these are JPEG images. And when we fetch the first one, for example, we get a typical HTML response with the name, the position, and the email. So the first thing we need to do is figure out who left Vuln Recruitment. It might be that they have old access that hasn't been revoked yet. What happens if we try to mess up with this URL, because it seems that it's fetching an image? I wonder if those images are stored in a separate server. So let's send this to the repeater and try to play with, maybe add a single quote. All right, it returns the same image. Now if I remove the 6 at the end, I get a 200 OK, but inside we have a 404 error code, meaning that we don't find this path. And it seems that we have a new subdomain here, b38f1-uploads. Let's record this new subdomain. We also do have the www. I might also look for other subdomains, but let's do that later. I'm going to just visit this web page and see what it has. File storage engine with a flag. Okay. So for this subdomain, we find the flag on the root. And it seems that we have a link here. The message says, welcome to the file storage engine. This is the home for your website uploads. There are many ways you can put your files on here. Maybe a file upload vulnerability. Why not have a Google search? Now, if we click on that, we're redirected to Google. And if we see the requests, we have the /redirect where URL equals the destination. Now, if I play with this a little bit, let's just use a junk domain, and it seems that it's redirecting to it. So this is a clear open redirect vulnerability. Now, open redirects are used to exploit clients, meaning redirecting them to your evil website, but they are also used to leak sensitive tokens such as OAuth tokens. Interestingly, it can also be used server-side if there's a SSRF. So let's continue our enumeration here. We were here trying to figure out what this hash is all about. Let's just copy it and paste it in CrackStation. Actually, let's just copy all of those. So we have 95, we have 0f, and we have 333, and all right, it seems that we have a hit for those hashes as MD5, and they represent what seems to be a timestamp. You can see here it's like 3 hours and 28 minutes maybe. So what happens if we try to brute force all the hashes that represent the time of the day? Let's do that and see what we get. We can try first of all to put a legitimate hash in the repeater but target the wrong employee. If you notice, we have the ID of the employee underscore and then the hash. Let's see what this gives us. All right, so we have a 404 even though we have a valid hash, and that's because we are targeting the wrong employee. So how to bypass this? It's very simple. We just need to go directly to this URL. We get the right image. Now let's take that request and send it to the intruder this time. And we're going to target this part here. But we want to fetch the image for the third employee. Remember, the one who left the company. And for the payloads, I'm going to generate all the times of the day. To do that, I can write a simple Python script. So Python, then I'm going to loop for hours in range 24, for minutes in range 60, and then I'm going to print those in 2 digits. So just like that, we have all the potential times of the day. We're starting from 0 and then we will end at 23:59. Let's copy this and paste it here. And this is where post-processing tools are handy. So if we add a rule here that says hash with an MD5 hash algorithm, Burp will automatically take each one of them and apply an MD5 hash before sending it to the server. I'm going to use a slow resource pool to just avoid being kicked out. And then I'm just going to start. Now, because we are targeting an image, there should be a significant difference in length. So we're going to reverse sort based on the length field and wait until we find the image if it is still available on the file server. And we get a hit with this hash. So if we use that hash on employee 3, ex-employee, we get our image here. Okay, so let's download it. I'm going to use curl with our URL, and I'm going to output it to our ex-employee.jpg file. And don't forget to add the B flag to add the cookie. All right, if we inspect the file, we can see that it's a JPEG image. Now, one great tool that allows you to extract metadata from files is exiftool, which is available on Kali, but you can also install it using apt-install exiftool. And it's as easy as running exiftool with the name of the file. And as you can see here, we have some important information, such as the GPS location. That seems promising because remember that we had to dig deep into one of the employees' data. So I guess this is one of the leads to use open source intelligence to look for some data. So if we go to Google Maps, so to do that, you'd have to format this correctly. So instead of degree, we can use the symbol and then remove the white spaces, then space, and same thing here. And we land on a location here near London. That doesn't give us any clue, however, so let's just save that location for later. Now at this point I don't have any new leads, so what I can do is perform more enumeration. And the first thing is to perform subdomain enumeration. I should have done this earlier, just to show you that if you don't do your enumeration right, you might miss a lot of things. So it's always good to have a methodology when you're testing your targets. So I'm going to start with DNS recon. As usual, I'm going to use the word list subdomains from CTF Challenge website and type brute force on this domain. Meanwhile, I'm also going to run asset finder on vuln recruitment. I'm going to use the option subs only. And it seems that it found our uploads subdomain, but nothing new. Our word list, however, reveals the admin subdomain. We get a message, you're not allowed access to from this IP address. So it seems that there's a check on our IP, and if we find a way to forge a request from within the same server or some kind of allowed servers like this subdomain, we might actually bypass this restriction. So at that moment I hit a wall and I needed a hint. And one of the members of CTF Challenge Discord server, Shamolash, gave me a hint about content discovery on the main site. If we go back to our main website, www.vulnrecruitment, you can see that we have staff and we tried to access various IDs. I also tried brute forcing the root path. It didn't yield any results apart from the JavaScript files. So I tried brute forcing under the staff path, and here I found portal. And the way to do this is just select that request. Actually, let's just go to the repeater and take our first request, this one, and send it to the intruder and do the same thing as we did with the hashes. The only difference here is that we're going to target anything under staff like this. And for the payloads, you're going to choose the word list from CTF Challenge. So if we go to the main website, staff, and then portal, we have a login prompt with email and password. Now remember that we already have a list of emails from our staff members. So we have Jacob, we have Archie, and we have Abby. So if we try the first one in the login form, let's just choose a dummy password. We have user does not have an online access. So this might hint that this user is not accessible. So let's rule that out. Let's try Archie. This one, we have a different error message. Invalid email password combination. This means that the user probably exists on the database. And Abby does not exist either. So let's try to brute force Archie. I'm going to send that request and catch it on burp. Here it is, a post request with an email and password. I'm going to do the same exact steps as before with the intruder, but in this case, you guessed it, we're going to target the password field. And for the payload, remember, we're going to use the CTF challenge word list that is dedicated to passwords. Here it is in the challenges word list. So passwords and password large. So I'm going to use passwords, paste them here, and then run the attack. All right, we find that it's Thunder, the password for Archie. So let's use that to log in. And it says we have sent a 4-digit code to your mobile. You have 3 attempts to enter it. Let's enter the first one, attempt, invalid 4-digit security. What about a dummy security digit code? Let's inspect that. On burp, we have the first post request with our password, with our first one-time password, the 4-digit, and we have the second request with our second one-time password. But in this case, notice that we have attempt equals 2. So this is controlled by the user. So what we can do simply is choose the first one, attempt 1, and brute force our one-time password without being rejected, meaning that we effectively bypass the 3 attempts restriction. So again, send this to the intruder, clear everything and target the one-time password. And for the payloads, this time we're going to use numbers from 0 to 9999 with a step of 1 to cover all of them, and with a minimum integer digits to set to 4 and fractions 0. So this is how they would look like, which is what we want, and just start the attack. I'm just going to use the slow resource pool and then start it. We would have a different status, maybe a redirect to the main page or a difference in length. We're getting rejected even though we're using a slow resource pool. So if we're lucky, our request would be accepted for the right one-time password. Otherwise, we need to rerun it with an even slower resource pool. All right, we found a hit here with a redirection, and it seems that our one-time password is this one. Can we actually reuse it? Hilarious. So we can even reuse the one-time password. All right, we note that. And inside we have a flag, and we also have something else. We have a messages and uploads tab. Uploads are only available to admins, but messages contain one email that has been sent from Archie, the current user, to Emily or Amelia, who is apparently the ex-employee, because we have all the best on your last day at work. You will be missed from the team. Okay, so let's try to log in with this email. So to do that, I'm going to go back to the logging and choose Amelia, and then choose a random password. And this time I'm going to use the same intruder process, but using the password long version provided by CTF challenge. I'll let you do this as an exercise, but at the end, Amelia has this password, ZXCBVBN. All right. However, note here that it asks us a secret question, and we need to answer that. What's the name of your local pub? All right, that rings a bell maybe. We can try the location of Amelia from our previous enumeration, open source intelligence. And here maybe we can choose the nearby and type pub. Okay, we have some hits here. The nearest one, I guess, is this, the new welcome sailor. Let's try it. And voila, we have access. And under payload, it seems that Amelia has been an admin and they didn't revoke her access. So I guess this is what the challenge meant by they have a serious security problem. So if we hit that button, we get a list of all our uploads, which we already have. However, if we inspect the requests on Burp, we can see a new request here, a post to uploads with listing file parameter. Let's try to play with it in the repeater. So here we have the list of files. I think this comes from the content of this file. Let's try to see if we can fetch the root path. All right, it seems that we have now another content here, which is nothing but the main uploads website. If you remember, we had file storage engine with the flag and then welcome, blah, blah, blah. So this is what I meant by leveraging Open Redirect server-side. Remember that we had an Open Redirect vulnerability here? So if we somehow trick the server to fetch a URL of our liking, in this case that would be admin, the server would fetch admin and we would bypass the IP restriction. So what happens if I take this and paste it here? Now remember that fetching the root path returned the upload subdomain, which is this one, so it makes sense to try the Open Redirect. Now if we send this, we get page not found, which is odd. And if I try an existing image like this one, I know that this page exists. I get page not found. So there is something here in the payload. It's getting transformed in some way. Now, if I remove the first leading /, aha, so now we have the content of the JPEG file. I think that we don't need the leading /, so let's put that here instead of our all payload. And it seems that we have an empty response here. I guess that's because we are using HTTPS. At last, we finally get the flag stored on admin subdomain. So this demonstrates that we have gained administrative access to vulnerable recruitment using the ex-employee's credentials. So that's it. I hope you found this video helpful. We covered subdomain enumeration, content discovery, open redirect server-side. We brute forced hashes based on how they were generated. We did some open source intelligence to bypass the security question. We did a lot of things here. We leveraged the SSRF to gain access to the admin subdomain. I always find the challenges made by Adam very entertaining and interesting.